So, welcome back. Today we want to try to build a 200 watt water-cooled LED for growing some lettuce and stuff. The problem with water cooling LEDs is the heat sinks are normally quite expensive. You can buy a cheap China heatsink like at this size, like R4 size, but it will cost you about $30 to $50, and there are way cheaper methods of doing that. And in our case, we're gonna use aluminium beams, 40 by 20 ones. You can get such an aluminium beam for like 1 meter, 7.5 euros. It's sometimes even cheaper. Well, yes, you have to cut them yourself, but that should not be a problem to cut them to the length you want. Then we need two 3D printed parts to connect the both beams. And then we need our 50 watt chips. I opted for 220 volt driverless 50 watt chips because I made actually good experience with them. This system implements the two beams. I made a test print. This is not the final version, this is just a 0.4 test, and you can see the upper side is already broken. But it doesn't matter, it's just for viewing purposes how it should look in the end. You have you can screw a 1/2 inch fitting in the top. I will replace this ABS fitting with two brass ones. So if you connect a hose, and so you don't break the neck of this thing here. I can show you the design. I think I made a time lapse about how I designed those. Maybe I can show it here or not, we will see. That's basically nothing more than an adapter from a beam to the fitting. And I will keep those in place with epoxy resin. Basically pour a little bit of epoxy resin into this ridge here and then press the beam inside, let it dry. Works. I tried it before, it works really fine. On the other side we can look. This is the piece where the water will flow through. So the water will go like this. You can see the stuff. So the water will go in here, then through the beam. Here those two holes are connected. It will go through and back through the beam, back out of the fitting, and then it will go into a radiator. Those are 40 by 20 with a 2mm wall thickness and cheaper F. Yeah, now the next thing is we're gonna make those look a little bit nicer. So we brushed up both. They're not perfect, but I assure you in real life they look a lot better than 5 minutes before. And they are quite shiny and reflective now, and those extrusion lines from the manufacturing process are gone. So next step would be printing another version of the end connections, this time with 0.1mm thickness.
Eternity later.
So we're back, like after 60 minutes of removing support material on those prints, and it looks kind of nice. So here we can add the fittings later, but now after we see that the rails, not the rails, the aluminium pipes fit, square pipes, now we're gonna glue them in place, but because right now they aren't in place. For this we're gonna use 5-minute epoxy. It actually works really nice with ABS and metal. I tried it before. So now we're gonna prepare the LED chips. We've got 4 pieces of them. And because I'm lazy AF, I'm just cutting those ESD bags open. we need to pre-solder them, because when they're finally onto the heatsink we have the problem soldering will then get kind of tricky, so we pre-solder them a little bit. And also we're gonna rough up the bottom side so that the thermal compound will hold better onto it. Next step is to pre-solder the chips. For this we're gonna use this little stand here, clamp them in like this. So, and then we're gonna use the soldering iron here, and just put a little bit of solder blobs. Alright, the next step will be placing the LEDs on there with thermal compound, but at first we have to find our layout for those, how we will place them. Voila. I think, yeah, this one and this one, that looks kinda nice. I think like this we will place them like this. So we wired up everything and we're ready to go. I'm gonna plug this in now. All we actually still need is the isolation for the soldering points. I will put epoxy on there too, but at first we're gonna test it and let's see if it blows up. I hope all the LEDs work. Yep, they all work. They all work. It's fucking bright AF. Okay, next time I'm gonna wear sunglasses. So, we saw everything from the LEDs worked, so the next step is to isolate the solder joints. So we are now about to take the first test to see if it leaks. I connected a water pump and we will see. If I switch the water pump now on, I hope we don't have any leaks. If we have leaks, it will show on the paper. And here we go. Yeah, it looks good. I mean, I'm not sure if you can see it, but we have ingoing water and outgoing water. The outgoing water still carries some bubbles from the air that was inside, but I think that will go away after a while. And I don't see any leaks yet. But we're gonna let it run for a while and see how it goes. You can still hear the water and air sloshing around. I will try to get the air out by turning it this side and then turning it this side. Yeah, sloshing is done. Oh, almost done. and you can see almost no air bubbles. And yeah, it seems to work quite nice. Everything seems to be tight. I don't see any water. Oh, was that water? No, it's not water, it's just cold. Because I am not mounted a radiator yet. By now I just have a bucket with cold water, and yeah, you can see it. You can't see, but it gets really cold. If I take my infrared thermometer and try to make a measurement, yeah. Ah, there was the problem. Yeah, you can see. I'm not sure if you can see it, but it's about 17 degrees. And for comparison, we have about 30 degrees right now in the air. And yeah, it's nice and cold. And it doesn't leak, which makes me very, very happy. Next thing we're gonna try is yeah, switch the light on again. But before we do that, I'm gonna get sunglasses. So I've got my cheap ass sunglasses, and we're gonna plug it in. Oh, even with sunglasses, this is so bright. I'm not even sure. Yeah, the camera only sees the chips now. I'm not even sure if this is good for the camera. I'm gonna turn it off again. Damn, that was bright. That was fucking bright. Let's just place some paper over it and try it again. Still bright, but now I can kinda look at it. I mean, damn, that's so fucking bright. Yeah, now we're gonna try to get the temperature of it. Just shield it with a hand and trying to get a reading. Yeah, I assumed that. The problem is, because it's such a shiny and reflective material, we can't get a reading. We get a reading for about 50 degrees directly on the chip, like in the center of the chip. And yeah, we can look at the drivers. Drivers are at 30 degrees. That's quite good too. But I can, with my hand, I can already feel the heat of the photons alone coming from it. Yeah, I think I'm gonna turn it off again. So try to give you a reading. Yeah. Oh, now turn it off. Oh, it's fucking bright. So, I'm not sure if you can see it, but that's the reading. 34 degrees are the temperature of the drivers. The temperature of the chips themselves are about 50, but I'm not sure my multimeter could, my ER thermometer could misread this. It's still cold, because, well, in the bucket are about 20 liters of water. This would take a while to warm up. We actually managed to build it. Our 200 watt water-cooled LED for material cost about, yeah, like below 50 euros.